Good morning everyone. I am Radharani. I am a student in Computer Science and Engineering in D section in Srinivasa Ramanujan Institute of Technology. Now I am going to do a video presentation in molecular orbital theory in chemistry. The subject code is 23Che-01. Let us know what is molecular orbital theory briefly. Molecular orbital theory is a method for describing the electronic structure of molecule. It uses the quantum mechanics to explain chemical bonding. In molecular orbital theory, electrons are not assigned to individual bonds but are treated as moving under the influence of all the nuclei in the molecule. This contrasts with valence bond theory, which describes bond between specific atoms. What are core principles of molecular orbital theory? Atomic orbitals combines to form molecular orbitals. The number of molecular orbitals are formed is equal to the number of atomic orbitals taking part in formation of molecular orbitals. Electrons fill molecular orbitals according to the Aufbau principle, Pauli's exclusion principle, and Hund's rule. Molecular orbitals span the entire molecule, not just two atoms, they are delocalized. What is linear combination of atomic orbitals? This is the mathematical process used to build molecular orbitals. Atomic orbitals are treated as wave functions. There are two main types of combinations, constructive inference and destructive inference. What is constructive inference? It is addition. It leads to a lower energy bonding molecular orbital. Destructive inference is a subtraction. It leads to a higher energy anti-bonding molecular orbital. Bonding versus anti-bonding molecular orbitals. Bonding molecular orbitals. These are two types, sigma bond and pi bond. It is lower energy than the original atomic orbitals. High electron density between the nuclei. Stabilizes the molecule and holds it together. Anti-bonding molecular orbital. These are also two types, sigma star and pi star orbitals. Higher energy than the original atomic orbitals. It has a node, zero electron density between the nuclei. It destabilizes the molecule and pulls it apart. Types of molecular orbitals. Sigma orbitals. It is formed by head and overlap of atomic orbitals. Symmetrical around the bond axis. Can be bonding sigma or anti-bonding sigma star. Pi orbitals formed by side and overlap of p orbitals. Have electron density above and below the bond axis. Can be bonding pi or anti-bonding pi star. Molecular orbital energy level diagrams. The molecular orbital diagram describes the chemical bonding in a molecule based on molecular orbital theory and linear combination of atomic orbitals. The molecular orbital diagram has molecular orbital energy level at center and it is surrounded by atomic orbital energy level. It shows electrons in both bonding and anti-bonding molecular orbital. How to read a molecular orbital diagram. Atomic orbitals are shown on the side and left side and right side. Molecular orbitals are shown in the center. Energy is represented on the y-axis and electrons are filled into the molecular orbital starting from lower energy level. Example, hydrogen. Electronic configuration is 1s1. Each hydrogen atom brings 1s electron. The two 1s atomic orbitals combines to form one sigma 1s bonding and one sigma star 1s anti-bonding molecular orbitals. Both electrons fill the lower energy sigma 1s orbital. Electronic configuration is sigma 1s2. It is the energy level diagram of hydrogen. Another example is helium. Electronic configuration is 1s2. Each helium atom brings two 1s electrons. The 1s atomic orbitals combine to form sigma 1s and sigma star 1s. Two electrons fill sigma 1s, two electrons fill sigma star 1s. It is the diagram of energy level diagram of helium. What is bond order? Bond order is a measure of bond strength and stability. It indicates the number of electron pairs in a bond. Bond order is a formula is bond order number of bonding electrons minus number of anti-bonding electrons divided by 2. Calculating bond order. Hydrogen have 2 bonding electrons and no anti-bonding electrons. Bond order is 1. Helium has 2 bonding electrons and 2 anti-bonding electrons. Another example is nitrogen. Electronic configuration is 1s2, 2s2, 2p6 and 3s1. Total valence electrons are 10. Bond order is it has 8 bonding electrons and 2 anti-bonding electrons. Divided by 2 is 3. This confirms that nitrogen has stable triple bond. Energy level configuration is sigma 2s2 and sigma star 2s2, pi 2p4 and sigma 2p2. Another example is oxygen. Molecular orbital energy level diagram of oxygen. Oxygen atom has electronic configuration of 1s2, 2s2, 2p4. Therefore, oxygen molecule has 16 electrons. In this formation of molecular orbitals, the electrons in the inner shells are expressed as kk, denoting sigma 1s2 and sigma star 1s2. The remaining 12 electrons are filled in molecular orbital as shown below. This is the energy level diagram of oxygen. It has antibonding and bonding electrons, and the middle one is molecular orbital diagram of oxygen. The electronic configuration of O2 molecule is sigma 1s2 to sigma star 1s2, sigma 2s2, sigma star 2s2, pi 2px2 equal to pi 2py2, pi star 2px1 equal to pi star 2py1. It has bonding electrons in oxygen molecule is 8 and anti-bonding electrons are 4. Therefore, bond order is 2. Thus, oxygen contains a double bond and O' bond length is 1.2 angstroms and the bond energy is 498.4 and it is paramagnetic in nature due to presence of lone pair of electrons. HUMO and LUMO. Highest occupied molecular orbital and lowest unoccupied molecular orbital. These orbitals are crucial in nature. Highest occupied molecular orbital. The orbital from which an electron is most easily removed, like a valence shell. Lowest unoccupied molecular orbital. The orbital to which an electron is mostly is added. Molecular orbital theory versus valence bond theory. Valence bond theory. It is simpler and more visual. It shows hybridization of sp and sp2, sp3. It views bonds as localized between the atoms. It fails to predict the oxygen is paramagnetic in nature. Molecular orbital theory. It is more complex but more accurate and powerful. It views electrons as delocalized over the whole molecule. It correctly predicts the properties like magnetism and bond order. Keys are antibonding orbitals are combined to form an equal number of molecular orbitals. Molecular orbital diagram shows the energy and filling of these orbitals. Bond order formula is bonding electrons minus anti-bonding electrons divided by 2. Molecular orbital theory successfully explains bond stability, bond order, and magnetic properties like example is of molecular orbital theory. The electrons in a molecule are present in various molecular orbitals as the atoms of the electrons are filled in various atomic orbitals. The atomic orbitals of comparable energies and proper symmetry combine to form atomic molecular orbitals. When an electron in a molecule is influenced by a nucleus, it is influenced by 2 or more nuclei depending upon the number of atoms in the molecule. Thus, an atomic orbital is monocentric with a molecular orbital is a polycentric. The number of molecular orbitals is formed is equal to the number of atomic orbitals taking part in formation of molecular orbitals. When two atomic orbitals combine, two molecular orbitals are formed. One is known as bonding atomic orbital and another one is anti-bonding molecular orbital. The bonding molecular orbital has lower energy and hence greater stability than the corresponding antibonding molecular orbital. Just as the electron probability distribution around a nucleus in an atom is given by an atomic orbital, the electron probability distribution around a group of nuclei in a molecule is given by a molecular orbital. The molecular orbitals, like atomic orbitals, filled in accordance with the Aufbau principle, obeying the Pauli's exclusion principle and Hund's rule. Thank you for watching my presentation. I hope you found it useful.